Hey everyone, so today we're going to be factoring trinomials when a is equal to 1 and c is greater than 0. In this PowerPoint, we'll talk about what a trinomial is, what a is, what c is, and how to factor given those circumstances. So let's get started. So some definitions that we need for this lesson. First one being trinomial, the sum or difference of three unlike terms. Hopefully you will feel familiar with trinomials. We worked with those when we were doing polynomial operations, when we were doing the box method and keep, change. So here's an example, 5x plus 6y minus 10. This is considered a trinomial because none of these are like terms, so we wouldn't be able to combine any of these. This is in simplest form. We can't go any further. So this is a trinomial because it has 1, 2, 3 terms, because tri means 3. Okay, next is a quadratic trinomial. This is new. Even though we've seen them before, we've never really referred to them as this yet. It's a trinomial in the form of ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal 0. So the key here is this x squared and a not being 0 because this needs to be a real number. The highest exponent of any quadratic expression or function must be 2. So if it does not have an exponent of 2, it is not quadratic. That's very important. If it has an exponent of 3, it's something else. If it has an exponent of 1, it's linear. The highest exponent has to be 2. Okay, so a is the coefficient of x squared. So that's in the title of this PowerPoint, we talked about a. So we're talking about this number here. That has to be equal to 1 in what we're talking about today. B is the coefficient of x. Remember, coefficient meaning the number in front of. So a is the number in front of x squared. B is the number in front of x. And then c is the constant, which is a number without a variable. So we talked about in the title that c has to be greater than 0. So c is going to be positive in the examples that we look at today. A is going to be 1, c is going to be positive, and then b is going to change. So let's keep going. Okay, so we want to be able to first identify a, b, and c. So identify a, b, and c in the following quadratic trinomials. You can take a second. You can pause the video and let's identify these. So remember, if there's no number in front of x, there's that invisible 1. So we have an invisible 1 right here. That's what a is equal to. A is equal to 1. B is the number in front of x, so that's going to be 9. And then c is the constant, the number on its own, so that's going to be 20. I'm going to just underline this 1 here. So a is 1, b is 9, c is 20. Notice I'm not including the variables here, it's just the numbers. Okay, so let's take a look at this one. Same thing, if there's no number in front of y, we're going to have a 1 right there. So that means a is equal to 1. B is equal to negative 6. I'm bringing that sign with it. And then C is equal to a positive 8. So I'm only bringing the sign with it if it's negative. If there's a subtraction symbol in front of it, treat it like it's a negative number. And remember, if there's no number in front of a variable, the invisible variable is 1. Okay, so when factoring, when a is equal to 1 and c is greater than 0, there's a couple things we need to think about. The important question of today that we're going to be asking ourselves constantly when we look at these examples are what are two factors of c whose sum is b? So this is another way of saying what are two numbers that multiply to c and add to b? Because remember, sum means add. So numbers that are going to multiply to our c term and then add up to our b term. And we'll see when we do examples, you'll see what that looks like. If c is positive and a is equal to 1, the signs of the binomial factors will be the same sign as b. So when we factor these, here's an example. Here we have a is equal to 1 and c is positive. So when we factor this, these are both going to be positive because b is positive. So these signs are going to be the same as whatever b is as long as a is 1 and c is positive. Now, when a is 1 and c is positive and b is negative, then the factors are going to be negative. So they're going to be the same sign as whatever b is going to be. Okay, let's take a look at an example. Factor the following trinomials completely. So what I like to do here is, like we said before, we want to find numbers that multiply to c and add to b. So we want to find numbers that are going to multiply to 14. So I'm going to put an m above that and add to 9. So sometimes I'm going to refer to this as the AM method. Math is better in the AM. It's a way to remember it. But numbers that multiply to 14 and add to 9. So if this doesn't come quickly to you, you can make a little chart where you're going to start with multiplication and then see if they add up to 9. So I'm going to list two numbers that when I multiply them, they give me 14. So example, 1 times 14 gives me 14, but 1 plus 14 does not give me 9. So that is not going to be the set of numbers that I want to use. Another set of numbers is 2 and 7. So 2 times 7 gives me 14. But 2 plus 7 gives me 9. So this is a set of numbers that work for both of these. They're two factors of 14, and their sum is 9. So those are going to be the two numbers that I use when I factor in my binomial, my two binomials. So I'm going to create two sets of parentheses. So b is going to go first in both sets. And then because this 9 is positive, then both of these numbers are going to be positive. So it's going to be plus 2 and plus 7. 2 times 7 is 14. 2 plus 7 is 9. So this is our answer. Let's take a look at another example. Here we have x squared minus 8x plus 15. So same thing, two numbers that when we add them together, we're going to get negative 8. And when we multiply them together, we're going to get 15. Now, like we said, if this is positive and this is negative, both of those numbers are going to be negative. So in my table that I'm going to create, both numbers, I'm going to have them be negative. So I'm starting with the multiplication. The reason why I start with the multiplication, okay, so I'm going to start with the multiplication. So multiply to 15, add to negative 8. The reason why I start with multiplication is because there are fewer sets of numbers that will multiply to give you 15 than there are sets of numbers that will add to negative 8. So that's why I always start with multiplication, because it just is a shorter list of numbers to work with. Okay, so two numbers that when I multiply them and they're both negative, that are going to give me positive 15 is negative 15 and negative 1. I kind of always start with that set of numbers because it's easy to forget that that is a set of numbers that does that. So that works here. That is going to give us negative 15. I'm sorry, positive 15. But when I add these together, that would give me negative 16. So that's not the set that I'm going to use because we want it to be negative 8. Okay, we also have negative 5 times negative 3. That gives us a positive 15. Negative 5 plus negative 3. That gives us negative 8. So those are the numbers that I want to include when we factor that. So I'm going to circle these, just like I should have circled over here. Okay, I'm going to create my two sets of parentheses here. X is going to go first in both of them. And then like we said, C is positive, B is negative. So that means both of these numbers are negative. So it's going to be x minus 5, x minus 3. Okay, a way to check this, you could do the box method or FOIL or distribute. It's up to you. But definitely refer to the rules that we talked about in the last slide, where if C is positive, well, in any case for today, A is going to be 1. But when C is positive and B is positive, they're both going to be positive. When C is positive and B is negative, they're both going to be negative. Okay, good luck.